Good morning. Thank you for coming back. My name's Jim Dehner. I happen to live in Nashville, Tennessee, and this is our second session of the Data Doctor. Now, today we're going to cover three topics. First, we're going to take a look at nulls and the different types of nulls there are in Tableau. Next, we're going to take a look at date functions and how date functions work. And then finally, I want to take a brief look at show hide filters. There are two different types of nulls in Tableau. There's what I call the empty cell null, and it looks like this. You have a data set that you brought into Tableau, and there's a cell right here. We have South, cats, and there's a cell there. There's a record for it, but there's no data in that cell. And that's what I refer to as an empty cell null. And you can see when we bring the region and type to the viz, we've got a blank in the chart. Now we can fill that blank in one of two ways. The easiest way, and this is probably the first calculation that you ever did in Tableau, is to use a ZN function. And ZN just simply stands for zero null, and we put the measure in the argument zero null or ZN quantity, and the ZN function will fill that with a zero. I also want you to look here at grand total. We created a grand total line and totaled that grand total line with average so that we can see the average of these four values is 20. There is another way to fill that cell, and that's by using the Format tab. And we can go up under Format and look specifically at quantity and come down to special values. And what special values will do, will insert a text value into the empty cell. And when we do that, it does put a zero in there. We could put something else in there. But first I want to go back and I want to do average again. And I want to total using the average. And you can see that the average is now not 20.0 like we expect, but it's at 80 divided by 3 because this value doesn't really exist. Okay, when we use the ZN, it put a zero in there and the value existed, and the average came out 80 divided by 4, which is 20. Now this value doesn't really exist. So now the average is 26.67. Now, depending upon your use, you may want to use this feature to input the zero as in for a null. I prefer to use the ZN when it's available. Now, there's an entirely different type of null in the data set, and that's what I call the no record null. Now, this data looks exactly like the data we were just looking at, but if we look at the data itself, and we come up here under South, we see we have South and dogs, but we don't have any cats. There is no record in the data set for South and cats. But when we look at the sheet, it looks exactly like what we were looking at before. And we can try to put a ZN function in here. And I'm just going to put that in place. And you can see that the ZN function will not, in this case, place a zero in the cell because the cell isn't there. There is no record in which to put a cell. Now there's a way to fill that cell, and you can do that with an expression that looks like this. And the way you would read this expression, starting at the inside, we use a table calculation, a lookup function. We're going to look up the sum of quantity at the current cell location. And if that returns a null, then replace it with a zero. Okay. And when we do that, I'm going to pull this off here. Then when we do that, we can see that we've dropped a zero in that place, and the chart looks right. Let's take a look at average again. We're going to take a look at the average, and we see that the average comes back 80. Well, that's not the average that you want. So the total is not going to work right when we use this lookup function. Well, in that case, what would you have to do? We're going to have to force a cell into the data set. We're going to have to fill that missing record with an actual cell in the data set. And we do that with a scaffold. And that's what I've done here. I've added a scaffold and I've forced the scaffold. Let's just open that up. I've created a scaffold that forces this South Cats record into the data set, and it fills all the fields with null values. And once we do that, then I can come back and use that ZN function we saw before to force a 0 into the cell, because now we've got one actually in the data set. And we can take the average of those values. Well, this is pretty simple to see because I've got a very small data set. And in the data set, you can say, oh yeah, I can see I have to add one value back out, one record back into the data, and then I can force a 0 into it. But it gets a little more complex when we're working with real data. And this actually came from a question that Segar had on using the Superstore data set. And what I've got here, I'm going to just pull the sales off to make it a little clearer what we've got. What we've got are all the customers that are in the Superstore data set. And we're just looking at 3 of the subcategories. And you can see the data is very sparse. And by sparse data, I mean there's holes in the data. There's not a whole lot of data available in some cases. And we can come back and look at this sales calculation. And we'll bring that up. And this is that if-then lookup function that we just looked at. And I can use that to force zeros into the data set. But you'll notice it only forces a 0 in the data set where there is another real value in the data. Okay? It wouldn't force a 0 into the data set in all of these cases where there is no real value in the filtered data set. So we're back at this point where we have to add records into the data set by using a scaffold. And to create the scaffold, I actually went up to Tableau Prep and created a scaffold. I pulled all the customer names in the data set, and I pulled all the subcategories in the Superstore data set, and then joined the two together using what's known as a Cartesian join. Value 1 equals 1, and every record in the first data set is matched with each record in the second data set, and that creates about 13,000 records. Brought that back into Tableau and joined it with the data. And once we do that, can use the ZN function again to force a 0 into the data, and now we've got a record that we can work with, and we can calculate using that record. Now, the important part here is there's 2 different types of nulls in Tableau, and they're treated differently. You have to treat them differently. First, there's the empty cell null, where you have an actual record, but you don't have any data in it. And that you can use a ZN function, and you put a ZN and force a 0 into the data set. If there is no record, then sometimes if you're not going to use that data in an actual calculation, and you just want to put a 0 into the viz so the cell's not empty, then you can use the lookup if null function that we showed you before. But if you're actually going to use the record and you want to count that record, or you want to do something with that record, you're going to have to come back and scaffold the data and join that into your original data set, and then you can treat it as any other data, any other record that you have in the data set. I want to take a look at date functions. Dates are a very special data class in Tableau, in the sense that they self-sequence, they self-sort, and you can use date functions. Now, dates actually come in 2 different types. There's date and there's date time. And what's actually happening in Tableau is the same sort of thing that happens in Excel. There's a floating point number down in the data that you don't see that represents the date and the time. And that floating point number on a whole number basis increments once for each day. And then the decimal part of that number represents the decimal part of a 24-hour day, and it can be broken down by hours, minutes, and seconds. Now, there's a hierarchy that's associated with that floating point number. And that hierarchy allows us to break that number into parts by different levels of the date that we'd like to see. And in the whole number part, that hierarchy starts at year, quarter, month, and day. And then after the decimal point, the decimal part is hour, minutes, and seconds. And we can look at that date at any one of those levels. There are also three values that are not in the hierarchy that we can also look at as part of the date part. That's week, weekday, and day of the year. Now, date functions allow us to look at that data and look at that date and to use it in other calculations or use it directly. And I like to look at date functions in 4 different groups based on what they return. There are those functions that return an actual date, and that's date trunc and date parse. And there's 2 other functions that are kind of grayed out here. These are actual data type conversion functions, date and make date. And you can make a date out of those from strings or from integer values. There are also date functions that return a reference to the date. They don't return the date itself. Like date name returns text. And if we're looking at the month level, date name would return January, February, March, and so on. The remaining functions down here return an integer value. And once again, if we were looking at the month of and using date part, January would be 1 and December would be 12. You can also do date math. You can add an increment to the date using date add, or you can add or you can take the difference between 2 dates using date difference. And then there's 2 special functions. That's today and now. And today is the date part of today, which would be May 26th. And now actually takes that down to the second. And I'm going to caution you right now to be very careful using now with a live database because you can create some real performance issues using now in a live database. But if you have to use it, you have to use it. Okay, let's take a look at the syntax for date functions and how they work. I'm using Superstore data again. This is the same data set that you've got, and I just want to look at the month and in the year of 2019. And the first function I want to look at is date part. I'm going to open up the calculation wizard, and if you're not familiar with the calculation wizard, I use it all the time when writing calculations. We can see all the date functions. They're sorted here. I'm going to take a look at the date function group. And a lot of these will look familiar. If you're experienced with Excel, you've seen a lot of these before, like year, month, quarter, those sort of calculations. Date part is going to return an integer value, and this will explain how the function works. The syntax for all of these is the same. You start with the name of the date function, and here date part. Then the first argument is the level in that hierarchy that we were looking at before. We want to look at the month level here. The level is always enclosed in quotations, and it's always lowercase and singular. We don't look for months, we look for month. And date part month order date is going to return the values 1 through 12. And that's great. And I use this a lot when I want to do date math and I want to do some math with the actual number. I can also look at date name. And we said before, the date name is going to return a text value, and date name month is going to be January, February, March through December. And this is a great way to put labels on your chart if you wanted to know the label at different levels in the date. Well, if that's what date part does, what does date trunc do? Date trunc is a function that is extremely useful when you're doing year-over-year calculations or year-to-date calculations. Date trunc returns the first day of the period at the level. So date trunc month order date is going to return January 1st for all the dates in January and February 1st for all the dates in February. It's actually a date time function. and it's returning January 1st at midnight, February 1st at midnight. Now, if we look at the quarter level, date trunk is going to return January 1st for all those dates that happen in January, February, March, all those dates in the first quarter. It'll return April 1st for all those dates in the second quarter. It's extremely useful when you want to do year-to-date functions or you want to do period over period calculation. We can also do date math. This is an example using date difference. And date difference is going to give us the difference between these two dates, between the order date and the ship date. Now, I asked for this at the day level. So we're going to look at the day level for the order date and the day level for the ship date. The way the function works is the order date is truncated at the day level, and it returns an integer. And then the ship date is truncated at the day level, and date difference returns the integer difference between those two values. We're not looking at decimal parts of a day. So you're looking at the difference between these two values, the order date and the ship date, truncated at the day level. And then once you have that, you can use it any way you want. I just used it to calculate the average shipping day by month. Now, one other issue that we have with dates, and we get this question a lot. A user will have created a chart that looks very much like this. They brought date to the two columns and they've broken it down to the month level and they put sales on it. And the question always comes back to say, well, these two things should join up. I want these to join up. Well, they're broken apart because we're using a discrete date. Now, instead of using a discrete date, I'm going to drag these off of here and just recreate this chart. We used a continuous date at the month level. Now we get a chart that looks like this, and this is kind of what the user expected to see. I've got a continuous date, and over the end of the year period, we're not broken apart into two distinct values anymore. The dates are continuous and they're connected together. But very often the question will be, well, how do I get rid of this white area at the two ends of the bar? Well, dates are unique in the sense that they can either be discrete or they can be continuous, and a little bit they can be discrete at the same time they're continuous. I can open up this green pill, come back down. You see it's continuous right now. I'm going to just call it discrete. And now I've got the chart. It's all connected together. These are discrete values now of a continuous function, and they're all connected together. This also has the advantage of I can come down into the axis and I can drill up and down in that axis. I can drill down to a lower level. This would be the day level, or I can drill up to a higher level. Okay, date functions are extremely useful. They take a lot of work. You need to be thinking in terms of what value is going to be returned, what type of argument is going to be returned to determine what function you want to use. My recommendation is to start with something simple, get a lot of practice with date functions because they're going to be extremely useful, not only in creating charts and data tables, but also when doing like year-over-year calculation, period-over-period calculation. I want to move on now to show high filters. But to do that, I have to spend a little time talking about the order of operation and table calculations. Very often we'll get a question where a user has created a chart and they want to see only a portion of the chart. And the question usually comes in without changing the underlying data table. And the question is very confusing, and we're going to try to demystify that at this point. To use show high filters, or to only show part of your data in the table, we're really using a table calculation. And there's a couple of different ways to go with different table calculations, but we're really using a table calculation. And they happen last in the order of operation. Okay. At that point, we've done all our filtering, done all our calculations, made our chart, and now we're down here at at the last step in the order of operation, we use table calculations to do the filtering. Now, table calculations are always done at an aggregate level. And when we talk table calculations, we have to talk in terms of scope. How much of the table are we going to look at one time, and what direction is the calculation going? Is it going across the data table, or is it going down the data table? So if we, just to give you an example of a table calculation, this is the way data usually comes into us. This is just sales by year, and I wanted to calculate a running total. And we can see the running total, and we can see that this data is giving us a running total across the data set. Not really what we wanted. I'm going to edit the table calculation so that we now include all the data, and we're not going to restart the calculation. So we now see that the data is continuous across the entire data set. And it would probably look a little better if we did this. So now we've got a running total that starts in January of 2017 and goes December of 2019. And usually we'll get a question that doesn't look like the data table. It looks more like this. The user has plotted that data. They included the continuous month of the order date, and they've got the running total just like we looked at here. And this one I happen to break down by category just so we had something to look at. And what the question that the user is really asking is they want to see the last like 12 values in this data, but they don't want it to start again at 0. They want it to run continuously from the start date that began in November. And they know if they just put a filter on it, and I just filter the order date here for the last values, it's going to come back and it's going to filter the data, but it's going to start at 0. And it doesn't really, the user really doesn't want that. What they really want to do, and if you think about this, you're looking through a window. You're looking at your data through a window. Right now, the window includes November 2017 all the way through the end of the data. And if we all we want to do is move that window to the left so that I'm looking at the last 15 days of data or the last 12 days worth of data. And we can do that with a lookup filter or with a show hide filter. And for this example, I'm going to use last as a show hide filter. Say if last is less than or equal to 12, then show the data. If not, then hide the data. Okay. And I've done that here, and I'm going to just show the data. And you can see now we get the totals out here all the way through December, but they're not starting at 0. They're starting at the value 1 year ago at December 2020. There's another way of doing that using lookup filters, and you might have heard people talk about lookup filters. I've set this lookup filter just to give us the value year-to-date value. Now, the lookup filter first requires us to do a calculation like this, and we're going to look up the order date. And all this says is look up the order date at the current cell level. And we're going to use that lookup date on our columns. We're not going to use the date on the column. We're going to use the lookup date on the column. And then we're going to come back and we're going to put a filter in. Now, this is going to get a little complicated, but it does use some date functions, so you can see how those work also. And all this does is take the year of the order date compared to the year of today. The date trunk year is going to be January 1st of today, and date trunk year order date is January 1st of the order date. It says if those two things are true, and also the date trunk at the day level of the order date is less than the date trunk of today's date, then show, and if not, then hide. And with that, we've got the same sort of show hide filter We got the same sort of show height filter. If we showed all the data, it would look like this. And we can use the show height filter just to look at the values for today, starting at the value on January 1st. So those are the three topics I wanted to cover with you today. We took a look at using show height filters and how you could use those, and how they create a window and how you can vary that window across your data set. We took a look at date functions and how date functions work and the syntax of date functions. And we also took a look at how you handle null values in your data set. I hope this was informative. If you have your own questions that you'd like us to take a look at, just let us know. You can either contact me or you can contact Sagar. And this is my contact information. And at this point, Sagar, if you have any questions, I'll try to answer them.